So today we're doing lesson 2.11, that's module 2, lesson 11. And your learning goal is related to what you did yesterday, but it's a little bit different. Today's learning goal says, I can use estimation to find a reasonable place to put the decimal point in the product. Okay? Yesterday we learned how to use area models and standard algorithm by renaming the decimal into unit form, right? Like when we had something like 34.2, we renamed it to be 342 whats? Tenths. And that's what helped us multiply, right? But today we're using a different strategy. We're going to really see how we can use estimation to find a reasonable place to put the decimal point, okay? Just like I was saying before, do you guys see how we used what we learned yesterday where we renamed a decimal, we got rid of the decimal point, and we renamed the unit in order to help us multiply? Yeah? We're going to take that knowledge today and carry it forward into today's lesson, but we're going to learn a completely different strategy today to learn where to put the decimal point in our answer. Does that make sense? Yeah. Okay. Yesterday, as you can see, we still had tenths in our answer, and that helped us put the decimal point in the right place based on what we knew about place value. But we're going to do something different today to figure out how we're going to put the decimal point in the answer. The first problem we're doing is 1.38 times 32. Okay? Now, let's first estimate in our heads. 1.38 is pretty close to what number?
138 hundredths.
No. 1.38 is pretty close to what factor that's a lot easier to work with? It's not 138. Is 138 easy to multiply in your head? No. We want to change 1.38 into a factor that's a lot easier to multiply in your head. Tell me what could be easier. 1. I love multiplying by 1. It's the easiest. Normally we could change this factor, 32, to 30, but since our first factor is 1, can we do 1 times 32 in our head? Yeah. So we can estimate that the product should be pretty close to what number?
32.
32. Okay, I want you to draw a box around your estimate just like I did over here, because today this estimate is going to be so important. That's like the key to life. Okay. Now, Kish, we're ready to think in our head. 1.38 is the same. If I want to get rid of that decimal point and just write the numbers, wouldn't I have 138? Yeah. But just so we know, is it 138 ones?
No.
No. Looking at the rightmost place over here, Eva, what place value is that 8 in? 1.38 then is the same as 138 hundredths. Good. Go ahead and write that down in your notebook. And you guys, did I erase? What if I want to change 1.38 to 138? Can I just erase the decimal point? No. How is the decimal point moving? It's actually moving 2 spots to the right, isn't it? So that's the same as multiplying by 100, or 10 to the power of 2. Okay? So there's 2 things you can think in your head. Either that 1.38 is the same as 138 hundredths, or if I want to get rid of that decimal point, I just need to multiply 1.38 by 100. Right? Do you guys agree? Good. So now let's use the standard algorithm, but let's just use whole numbers. So if I get rid of the decimal point, I have 138, and I want to multiply that by 32. Okay, now I can use my good old standard algorithm to multiply the numbers. 2 times 8 is 16. 2 times 3 is 6, plus 1 is 7. 2 times 1 is 2. Now I'm working in the tens because it's really 30 and not 3, so I'm going to put a 0 there. Super important. Oftentimes we make mistakes because we don't put that placeholder 0. Then we have 3 times 8, which is 24. 3 times 3, which is 9, plus 2, which is 11. And then 3 times 1, which is 3, plus 1 is 4. Those are both partial products. So when I add it up, I have 6, 1, 4, 4. 4,416. Yes?
Yep.
Okay. Now, what did I do? Actually, here, let's take a look. What was our estimate? We said our product should be around what number? 32. So now I have 4,416 down here, right? Where would I need to put the decimal to make it as close as possible to 32? If I put the decimal point here, at the very end, what number do I have?
4,416.
Okay, is that close to 32?
No.
Okay, what if I put the decimal here? What number do I have now? 441.6. Is that close to 32?
No.
What if I put the decimal point here? 44 and 16 hundredths. Is that closer to 32?
Yes.
What if it's here? 4 and 416,000.
No.
So where could I put the decimal that it would be the closest possible to our estimate of 32? Akshay? Between the 4 and the 1. So I think my answer probably needs to be there. Think about it. If my decimal point was here and I moved it 2 spots to the left, is that the same as dividing by 100? I have to do that because originally, to get to the whole numbers, I multiplied by 100. Do you see that? So I have to undo that multiplying. It's like I temporarily made it 100 times bigger, just so I can only have whole numbers. But then when I get to the end, I have to take away, divide that 100. Does that make sense?
Yeah.
Good. So do you see how we were able to use our estimate to find a reasonable place to put our decimal point?
Yeah.
Very good. This estimate tells me, by estimating and rounding the factors, that my product should be somewhere in the range of 10,500. Do you guys see that?
Yeah.
Okay. Now, let's take this first factor because it has a decimal point. Okay? If I want to get rid of this decimal point, what do I need to do? I'm going to have to move it to right here, right? So if I move it there, I'm shifting it how many spots? 2. To the left or to the right? To the right. So is the number getting bigger or smaller? So I'm multiplying. To get rid of the decimal point, I'm multiplying by what? 100. I need to remember that I'm doing this because that means at the end, to undo that, I need to do what? Divide by 100, okay? Very good. So now that I've done that, what's my new factor? If I multiply 147.83 by 100, I get rid of the decimal point, and my new factor is 14783, right?
Yeah.
Okay. Are there any decimals in my next factor? No, so I don't need to change it. So I can just multiply now. If I just have whole numbers, can I multiply? I sure can. Let's do it. So now that we have our multiplication, we can see we have 990,461. Okay. But is that close to our estimate of 10,500?
No.
Let's think about where we would need to put our decimal point to make it closer to our actual estimate. If I put it here, I have 990,461. Is that close to our actual estimate?
No.
No, okay. If I put it here, I have 99,046 plus 0.1.
No.
Is that close to 10,000? Is 99,000 close to 10,000?
No.
No. If I put it here, I have 99,904 and 61 hundredths. Is that close to 10,000? Is 99,000 close to 10,000? Yeah. Is it closer than anything else we can get?
Yes.
That's the closest we can get. So where do we think a reasonable place to put the decimal point will be? In between the 4 and the 6. So if I put the decimal point here, based on our estimate, right, because that's what will make it closest to our estimate, let's think about it. It started over here, and how many times did it have to move?
2 times.
To the what direction?
Left.
So is that the same thing as dividing by 100?
Yeah.
And do you see how that's undoing what we did originally?
Yeah.
Very good. So your total product is 9,904 and 61 hundredths. So you have 2 strategies today that you're learning, actually. You're learning how to multiply to get rid of the decimal point at first, and then dividing at the very end to undo that. But you're also using your estimate to help you see what a reasonable place is to put your decimal point. Does that make sense?
Yep.
Good. It says, use what you know about place value to put the decimal point in the second product. Okay, so I already gave you some information. 98 times 768 is equal to 75,264. Okay, so if that's true, then what do you think the answer to 98 times 7.68 is? Do you have to do the math?
No.
Talk to your table group. I want you to write down the first statement and then write the then, and then see if you can write the second statement together as a table group. Would you guys agree with me if I said that these 2 math sentences are related?
Yeah.
Okay, let's compare factor by factor. 98 compared to 98. How do they compare?
The same.
They're exactly the same. Okay, 768 compared to 7.68. How did those 2 compare? How did I get from the top one to the bottom one? What did I need to do? Marvin?
You just needed to divide it by 100.
Divide by 100. Do you guys see how basically the decimal point used to be here, but I moved it 2 places to the left, and now it's there?
Yeah.
Right? So 7.68, is it bigger or smaller than 768?
Smaller.
How much smaller?
100 times.
100 times smaller. So how is that going to affect the product? It's also going to be
100 times.
100 times smaller, right? because I'm dividing it by a smaller thing. I mean, I'm multiplying it by a smaller thing, sorry. So, how can I take this number, 75264, and make it 100 times smaller? This is all the way back to Module 1, Lesson 1. What do we need to do to the decimal point? Wait, first of all, there is no decimal point. 75264. I don't see a single decimal point there. Stella, where's the decimal point?
The decimal point is between the 2 and the 6.
Wait, no, I don't see a decimal point between the 2 and the 6. I'm asking 75264. Where's the decimal point right now?
After the 4.
After the 4, right? And so if I need to divide by 100, I need to move it 1 time to the left and 2 times to the left. So Stella, you are right. The decimal point needs to end up in between the 2 and the 6. So do you guys see how you can use given equations